So, I'm not sure how familiar you guys are with basketball, but that's fine. So, suppose we want to get box scores for every basketball game in the country this year. So I showed you the one URL for that one game, right? But there are 351 teams in Division I basketball, and they each play about 30 games a year. So that adds up pretty quickly. And you can't just do all that by hand. So I kind of split this goal into three main parts. First, we want to find all the teams. Then we want to find all the games that they played, and then we want to retrieve the box scores from those games. So in steps 1 and 2, essentially what I'm doing is finding URLs to reach. And then in step 3, I'm on the final page, and I want to select certain objects from that page. So that's why I use the RBEST package. So for step 1, we have our list of teams. So again, I said there were about 350 teams, lots of different names, things like that. So we're trying to grab Albany and Binghamton and things like that. In the page source, I'll zoom in a little bit. Here's Albany, right? So this is what we're trying to grab. But we also want the team ID, this 399, because that'll help us get to the next URL that we need. So those are what we're trying to find within here. So you go to the web page, and in there I tried to find some sort of string or list of characters that showed up, was identifiable with the teams. Since they all have different names, you can't just look for each team name, so you want to look for something that shows up near where they show up. And what I eventually found was this quote, BI quote. See, it's right next to Albany, and it's only there once for each team. So that sort of took some looking through, and that wasn't something that came very easily. And that's going to be a little bit different every time. A lot of times you'll have something much longer than that you need to identify what's going on. This time I kind of got lucky. So we have that. This stir locate all is a function in the string R package that it uses to cover up some of those regular expression things and make it a little more user-friendly. And so then I found where in the HTML they were and where within the lines those characters occurred. And so then in here, essentially I'm just using substrings again and splitting them by different characters to get rid of all the excess that comes when you pull out the whole line. And so here's our result. We have this list of the teams and their team IDs. And so in the future, we can add this to our URL and say, now we can access, if we want to see Albany's web page, we can go to that URL with 399 at the end. And so that's where the step 2 comes in. So now we have a team web page. I chose NC State again. And we have all the games that they've played this year. Right? So what we're trying to grab are these web pages now. So these are the URLs that will take us to the box scores that for the games they played in. And so if you look through the HTML, this page, you can eventually see that it goes down to line 389 after staring at it for a while. And so that's where all the actual games are located, the games that they've played so far. So elsewhere in the document, there's games that they haven't played and things like that. We're only interested in the games that they've played so far and pulling information from there. So this game ID right here, this 400, lots of other numbers, is what we're interested in grabbing to get to our final URL. So to find these, you can look for the string game ID. In this case, it showed up for each game. There was just a game ID within that line, which identified it. And so eventually you can take the substring that has game ID to the rest of the line and cut out whatever comes after that. I think this slash quote was where the IDs ended. So you can't just pull out a certain number of characters because IDs might be different lengths and they all look different. So you have to look for something that signifies that the ID is complete. So that's what I did there. And so we get all these game IDs for our season. And so the nice thing about doing this kind of scraping instead of just pulling it all into a database and holding it there is that this will update every time the website changes. So if you follow our basketball team, then you know we've played 22 games this year. And so we have 22 game IDs here. When I was making this presentation earlier, we played 21, so it stopped here, and it's since changed since the website has been updated. And so again, we can take these game IDs and build a new URL that'll take us to the box score. And then we have the box score. I'll close a few tabs here. So here's where we're at our final page. Right, we're back here again. And instead of the team names, we're interested in all this information here, these actual tables with the numbers, the game stats. And so essentially I combined all the piping code that we saw earlier into something that just lets you put in the URL and the selectors you're interested in, and it'll give you the text back. So on here, we're interested in finding these labels. So we want to know what they're called, the minutes, the field goals made, things like that. And then we're also interested in learning about the starting players and the bench players, which are separated on this website. So they're actually two separate tables. And so we look through with the selector gadget. So we want to find these values, right? But we don't want team names, and we just pick one of these because they're all the same. And so now we have this CSS selector. I think I chose a different one on the slide, but they're all the same. So that gives us the information we're looking for. So for the headings. And we're also interested, as I said, in the starting and bench players, which are separated. So they have different CSS selectors, depending on what you're interested in finding. And again, we run this function on them and do some transformations. And here we have the starting players and stats about them. And from there, you do the same thing for the second team. And I added some columns. I separated. Here we had field goals made, dash attempted. So I split that into two columns. Field goals made and attempted, things like that, that are more useful for us to analyze basketball results. And you end up with two data frames that look something like this, plus some extra columns. So that was basically the whole example. In summary, web scraping allows us to kind of pull information in an organized manner from websites. These XML and string-R packages have really good abilities to parse different kinds of web pages. And the RVS package allows us to sort of pick and choose what we're looking for. And that's all.
Any questions? I just have a question. I was a little confused about the XML. So ESPN isn't necessarily organized with like the game ID, and then the code is helping navigate.
Yeah, so like on this particular website is not through ESPN, and it happens to be organized in this way. So certain websites have this kind of tree format that allows you to pick off branches down the line, but the ESPN ones did not.
Right,
so that's why I had to use a different package.
Okay.
Yeah. All right. Well, I will have the code. Oh yeah.
So I mean, it sounds like you've been doing this for a little while. I mean, has the ESPN, like the structure of the page, stayed pretty much the same? Or like how, like, are there ways that like you thought of where like if the format of the page changed, you could maybe identify that, and then if it broke, if you wouldn't be too surprised or too out of luck?
So I've been working on this basketball example for like a week or two, but the other ones that I've worked on are all a little bit different. So like when I was scraping some fantasy football information, you can look at like projections and the values that players end up getting and things like that. And that's a different format than the ones that I was doing before. So you do have to kind of start and look at the data for that particular project and understand the format. This one was actually organized in tables. So I was able to use XML to use like one table command and just scrape the whole table, which is really useful. But a lot of other ones aren't that easy.
And I will say ESPN is nice in that if you look at the football box scores, all the football box scores they have are all the same going back to like 2001 when they started.
Okay.
So it differs by sports and everything, but once you're in a sport, they're pretty consistent.
Yeah. And yeah, I figured that out by checking, writing the code for one page and then checking one or two others, and it seemed to work pretty well.
Say you were to move into the play-by-play, well, that's got the table's a lot of links in it too, and then you have to do further parsing. How would that work on with it? Like you wanted to scrape when each of the events in the game happen.
That's something that is a future goal of mine. So I don't exactly know. Yeah, I see they have blanks. I think I've scraped this one time with the string R package, and it has two columns, one for each team. So there are, NA values or some sort of blank indicator that you can eliminate, and they each come with a time stamp on them. So in this particular case, I think that works out. I'm sure there are other cases where you have to be more particular about it.
Out of curiosity, once you get this data, what are you doing with it?
It's a good question.
Those are trade secrets.
I don't exactly know yet. So right now, I have some code that will loop through all 350 teams and find all their games and find all their box scores. And actually, it has to pause in between finding those things because ESPN gets a little upset if you try to query 6,000 pages at once. But I don't exactly know yet. I think maybe build some sort of shiny or interactive thing that will let people without this background find the right games that they're looking for and download them in a format that can let them analyze it. Yeah. Yeah.
So say you're scraping like all the games for all the teams for the current season. How long does it take? Is it pretty quick?
So I haven't done it all in one step. To get all the teams and all their games, it was like less than a minute. Yeah, it was very fast. Okay. Yeah.
Jason and I downloaded all of the pitch FX data for like 3 years. That took like an hour. So that's a lot of data.
Yeah, that's definitely more data than I've been dealing with. Because I'm just looking for those numbers within the URL. I'm not keeping any other information. So.